All right, so binomial theorem, which is section 12.7 in your book. Before we can talk about binomial theorem, we are going to go back and talk about Pascal's triangle. So recall the method that you would use to build Pascal's triangle. You start with these three ones in this triangle, and for the next row, you always start with a 1 and end with a 1. And then you would take the two numbers above and add them together to get the number underneath. So to get the next row, we start with the 1, add 1 plus 2 to get the 3, the 2 plus 1 to get the 3, and you end with the 1. And you can see how each row after that builds accordingly. So we mentioned a few different things that Pascal's triangle is useful for, but we haven't really talked about what we're going to use it for. And that is when we look at binomials that are raised to a power that we want to expand. So let's, for example, take a plus b quantity squared. If we were to expand it, this is what we would get. All right, cool, we're good with that one. Let's talk about a plus b cubed. If you actually worked it all out, this is what you would get. And take a look at a plus b raised to the fourth power. Now, did anybody pick up on where these coefficients are found in Pascal's triangle? We've got 1, 3, 3, 1, 1, 4, 6, 4, 1. If you guys notice, those are the actual numbers in each of these rows of Pascal's triangle. So what Pascal's triangle can do for us is give us the coefficients of the terms when you expand a plus b raised to the nth power. These are called binomial coefficients. So you can see each of these is when n is raised to a certain power. You can figure out which row you would need. It's based off of this second number being n. Okay? So that will be useful. All right, so the next thing that you should have picked up on, hopefully, looking at the exponents for a and b. And as we move along in the terms, you should see that the exponent for a is decreasing by 1, while the exponent for b is increasing by 1. And that right there, coupled with the binomial coefficients, is really what the binomial theorem is all about. So you can imagine that if we tried to do a plus b raised to the fifth power, we know we would use this row, and we know that a would start with a to the fifth, and then a to the fourth, a cubed, a squared, a, and then a would disappear. Where at the same time b would not be in the first term, b to the 1, b to the 2, b cubed, b4, b to the fifth. So you could probably expand any binomial raised to the nth power without actually ever looking at what the binomial theorem looks like, right? Okay, well, we're going to still look at it. This is what it looks like. Okay, so this is what it looks like when it's written in its sigma notation. You guys should be able to read this off pretty easily. We know that when k equals 0 all the way up to k equal to n, we would plug in those numbers, k and n. We have the x raised to the n minus k and y raised to the k. And we can see that n is the exponent that we're raising our binomial to. And that's always going to be up here when we do our combination. And this is actually giving us the binomial coefficient. Okay, so now if we expanded this, it looks like a big old mess, doesn't it? Okay, well, that's okay, because remember, we would be able to do this without ever having seen this at all. We know the pattern, right? That the exponents for the first term are going to be, or for the first variable, are going to decrease by 1 each time. And then the exponents for the second variable are going to increase. And we know where these coefficients are coming from too. Okay, so let's actually practice. Let's try expanding 2a minus 5b raised to the fifth power. First of all, we know that this is the row that we're going to be using from Pascal's triangle to get the coefficients. So our first term, we take 2a and raise it to the fifth power, coefficient with 1. Next term, we have our coefficient of 5. Then we're going to take 2a and raise it to the fourth power. And then we have to have the negative 5b raised to the first power. Next coefficient is 10. Then we have the 2a cubed and the negative 5b squared. and so on and so forth. You can see what all of these are going to end up looking like. So once we write all of that out, now we have to go through and actually multiply everything together to get the final answer. So you have to watch out for a couple things. When you have a coefficient for one of the variables in your binomial, you got to make sure that that is also being raised to that exponent. So as you can see, all of these would get multiplied out with their exponents. Also notice that every time the negative 5b was raised to an odd power over here, the plus turned into a minus, right? You guys notice that? Okay. So now that we've done that, we can multiply everything together and we get our final binomial expansion. So it's kind of tedious, but not impossible, right? Okay, so what else could we do with this? Well, aside from expanding a whole thing, we can actually look for a specific term. So if we were trying to find the tth term, I know that's kind of funny, of a plus b raised to the n, we're going to use this formula. So we're going to use this combination to actually figure out the binomial coefficient as opposed to looking at Pascal's triangle. So we're going to have n choose k, and k, this number that's going to be on the bottom, is one less than the term you're looking for. So if you're looking for, say, the 12th term, k is going to be 11. And then we have a, which is this number, raised to the n minus k. So you would subtract these. And then you have b, which is that number, raised to the k. And once you work all this out, you would have that specific term. So let's do an example. Find the third term of x plus y raised to the 15th power. So n is 15, and we're looking for the third term. So our binomial coefficient here, 15 choose 2. Remember, this is going to be one less than that. And then we take x raised to the 13th power, because we do 15 minus 2, and then y to the second power, because it's just k. You work all of that out, 15 choose 2, you get 105, and there's your answer. Okay, let's try another one, a little bit more difficult. Find the fourth term of 2x minus 3y raised to the 11th power. So we know that n is 11. Since we're looking for the fourth term, k is going to be 3, 1 minus it. Okay, so we have 11 choose 3, and then we have the whole quantity of 2x raised to the 8th power, 11 minus 3, and then we have negative 3y raised to the 3rd power. And now don't forget that we do have to take 2 and raise it to the 8th, and take negative 3 and raise it to the 3rd, as well as taking 11 choose 3 in order to get our final answer. Okay, so that's it. That's enough for you guys to be able to do all those problems in this section. Hopefully it's not too bad, and good luck.